Are you preparing for a principal software engineer role at JPMorgan Chase, JPMC, or any top financial institution? This video is a complete guide covering system design, Java backend, microservices, AWS, and AI integration, everything you need to crack senior level interviews. About JPMorgan Chase. JPMorgan Chase is one of the world's leading financial institutions, known for its strong focus on security, scalability, and reliability. Given the nature of banking systems, applications must be highly available, fault-tolerant, and compliant. The organization is also heavily investing in cloud-native and AI-driven solutions, which aligns well with my experience. Role overview. This role is highly hands-on, with around 80% focused on coding, design, and troubleshooting. As a principal engineer, the expectation is not only to build systems but also to define architecture, guide teams, and ensure engineering excellence across the organization. Key responsibilities. My responsibilities in such a role would include designing scalable frameworks, ensuring best practices, and building secure and high-performance systems. Additionally, I would mentor engineers, identify gaps in existing systems, and drive improvements across architecture and processes. Tech stack. The core stack revolves around Java and Spring Boot, along with advanced Spring frameworks like Spring Cloud and Spring Security. On the cloud side, AWS services such as Lambda, ECS, S3, and API Gateway are used to build scalable systems. We also leverage Kafka for streaming and CI/CD tools like Jenkins for automation. Cloud and DevOps. In modern systems, cloud-native design is critical. I focus on building applications that are containerized, deployable via CI/CD pipelines, and observable using monitoring tools. Automation and infrastructure as code play a key role in ensuring consistency and reliability. Microservices architecture. Microservices architecture enables us to build loosely coupled and independently deployable services. Key components include API Gateway, service discovery, and resilience patterns like circuit breakers. This architecture improves scalability and allows teams to work independently while maintaining system reliability. Database and performance. Performance is critical in banking systems. I focus on efficient data modeling, query optimization, and leveraging caching mechanisms like Redis. Additionally, JVM tuning and connection pooling help improve application performance significantly. Streaming technologies. Streaming platforms like Kafka enable real-time data processing and event-driven architecture. They are particularly useful in banking use cases such as transaction processing, fraud detection, and notifications. AI and modern engineering. AI is becoming increasingly important in enterprise systems. Technologies like retrieval-augmented generation help improve the accuracy of AI systems by combining LLMs with external data sources. I focus on integrating AI capabilities into existing systems while ensuring scalability and security. Leadership expectations. As a principal engineer, leadership is a key responsibility. I mentor engineers through code reviews and design discussions, promote best practices, and help teams grow technically. I also influence architectural decisions and align technical strategies with business goals. Testing and quality. Ensuring quality is critical. I follow test-driven development practices and use tools like JUnit and Mockito for unit and integration testing. Automated testing helps maintain system reliability and reduces production issues. Security and API design. In financial systems, security is non-negotiable. I implement OAuth 2 and JWT-based authentication, secure APIs through gateways, and follow secure coding practices to protect sensitive data. Agile and tools. I work in agile environments using Scrum or Kanban. Tools like Jira help in tracking work, while GitHub and Jenkins support version control and CI/CD pipelines. This ensures faster and more reliable delivery. Key skills summary. To summarize, my expertise lies in Java and Spring, microservices architecture, cloud-native development, performance optimization, and AI integration. Along with technical skills, I bring strong leadership and strategic thinking capabilities. Interview questions. Java and Spring Boot. If asked how I design scalable applications, I emphasize stateless services, caching, async processing, and proper layering. Microservices. For communication, I prefer REST for simplicity and Kafka for event-driven systems. AWS. I design deployments using ECS or Kubernetes, API Gateway, and CI/CD pipelines. Performance. I focus on JVM tuning, DB optimization, and caching strategies. Kafka. I highlight its scalability, durability, and suitability for event-driven systems. AI. I explain RAG as combining LLMs with external data for better accuracy. Leadership. I emphasize mentoring, code reviews, and enabling team growth. Advanced scenario. If asked to design a banking transaction system, I would use microservices for accounts and payments, Kafka for event-driven processing, and ensure strong consistency at the database level. Security would be handled via OAuth 2, and the system would be designed for high availability and fault tolerance. Final tips. In conclusion, success in this role requires strong system design skills, hands-on coding expertise, and the ability to lead and influence teams. I focus on delivering scalable, secure, and high-performance systems while continuously driving innovation. Thanks for watching. Like, share, and subscribe for more interview preparation content.